Well, hello and welcome to another DevNation Live. I'm super excited to have you all here today, and we have another great guest speaker to come spend time with us right now. So you guys are going to hear a lot about microservices and specifically testing, and maybe less microservices and more about testing. Because one of the things we want to do in these sessions is ensure that you guys also have great background information that'll cover your day-to-day development needs. So if you have other topics you have interest in, please feel free to email me. Most of you have my email address at this point since the announcements go out with my reply to. Feel free to just send me an email and say what else you'd like to hear from us. Also, you can hit me up in the chat. I've been trying to follow it here, welcoming folks from all around the globe. It is super exciting to see everybody from all around our world, if you will, to come in and spend a little time with us every other Thursday or so. So we meet the first and third Thursday of the month. You can always go to developers.redhat.com/DevNationLive to see our upcoming schedule. But at this point, I'd like to turn it over to Alex Soto Bueno. He's coming to us from Spain. I believe he's specifically in the Barcelona area, but I'll let Alex introduce himself. He has a great testing topic to talk to us today.
Hello. Yeah. Today I'm going to start talking about a new tool that we've been developing in the last year in the testing group, which is it's called test or smart testing. It's called the tool, which allows us to not run your test with more fashion and faster, and you get results in a better way. My name is Alex Soto. I work in Red Hat. I'm the creator of lordsofthecharts.com, and yeah, I mean that you can follow me on Twitter, which is Alex Soto B. And as I said, I'm the co-author of Testing Java Microservices from Many. And as I said, we're going to talk about testing. And I would say that the world is moving so fast. Traditional business are changing into software world. We've seen this in Uber, Just Eat, or Airbnb. All these companies have taken the traditional business and moved to the software companies. And if we want, and as a software company, we need to adapt to these changes to survive as well. And this means that we need to release our software faster, because maybe there is a bug on our software and we need to, get it on production really quick. Sooner, maybe because we want to get some really cool new feature for our competitors. And of course, better. I mean, that you can have a really cool feature, but if it does not work, it's somehow useless. And to go faster, to go faster and sooner and better means writing more tests, and we need to automate everything. So just a really quick overview of the lifecycle of the continuous integration, continuous delivery from the point of view of testing. Usually you are a developer, which you do git pull, rebase, revision master, or whatever. Just you get a lot of changes from your git repo. Then probably you create a new branch, and then you try to make a clean test to run all your tests to get it that everything's working as expected on your machine. After that, you start coding your new feature, writing the automated test, writing the new feature, and so on so far. And then just run maybe a clean test to validate that everything is working as expected. After that, probably you are going to commit your changes. Then you do a checkout of the master. You get the latest changes from the Git repo, because maybe between you have started developing something and now there has been some changes. Then you revise these changes to your branch. And finally, you need to run again maybe a clean test, because if there has been some changes, it means that maybe something has been broken between your test and the new changes pulled from the Git repo. So you need to run again all the tests. Finally, if everything works as expected, you have green and you don't have conflict and so on so far, you push this new branch to your Git server. Then probably there is a webhook which sends a pull request, and this pull request will run some pre-commit tests in your CI/CD server. Again, you're running again some tests to validate that everything works as expected, and after some code review, you can decide if you want to merge these changes to your master branch or not. If you decide to merge it, you have an approval, and then you have the commit stage test, where you again run tests. These basically are the quick tests, which gives you feedback about the quality and that to be sure that you have not broken something important. And finally, you run acceptance tests to validate that all the solution works as expected, and then you can deploy this to production, right? So you can see you run test, test, and test in several places. Then, if you check this quote from Canva, say that as an engineer, you should constantly work to make your feedback loops shorter in time and wider in scope. So basically, what we want to do is just do not spend times in front of or the monitor just checking if all the tests are green in all of these phases. And the good thing is that most of the time you already know which test you want to run, because you know that which test which production code. So usually what you do is just you have your IDE and says, okay, I've added this feature, and I know that this feature changes this part of the code, so I know that I can run all these tests. But it's at the end, it's a manual process. The automatic process still takes time and time. So what we have done is just take this knowledge and put it so you can get it in automatic way. And I think that the best way to show this is with an example. I've got here a really simple application, which is a game. In this case, well, I'm going to explain you now. I've commented this test, basically to not write it now. So I just implemented this test. I create, for example, a new feature, and I want to test it. So then I'm going here, and I can do Maven clean test, right? This is usually what you do. And then you will see that the build start working, or hope so. But basically, the idea you get here is that this project has several tests. Maybe it has like 20 tests or so. So you're going to compile all your project and just, running all the tests of this project, which probably is going to take some time. Now see that if you check the project, it's a multi-module project. It's a monolith project, but it means that this works with microservices, with a monolith, whatever. It doesn't matter. This approach works with any Maven project, because basically this smart testing tool is a Maven extension. So now I'm not running a smart testing at all. I'm just doing as usually, but I think that it's going to take a lot of time because of sharing the screen. But well, you can see that I'm running here tests, then get the next module, and also it's going to run more tests, which is the tail test, for example. And if you check here, you'll see that the one that I've changed is the game service test. Again, it runs all these tests, the tail service test, which I mean that it's a Java EE application, which is done with JPA, CDI, HGVs, and so on and so forth. So you need, for writing the test, you need to boot up the database and run all the entity and boot up the entity manager and so on and so forth. So, well, it's just building all the project. Of course, I mean that this is a small project, but if you think about in a big project, usually this is what happens, right? That you are just there compiling and running tests from your project. And in this case, for example, this is a game resource REST API test, which is like a smoke test, which just package everything, boot up, and just run a smoke test to validate that all my changes still works or fits together. Notice that in this case, I'm using Wi-Fi. So it needs to start Wi-Fi, create the WAR file, deploy this WAR file inside the Wildfly, deploy it, and so on and so forth. So it takes some time because you need some time to execute it. But I'm going to just to save time, I'm going to abort the build because it takes a lot of time. But as you can see in the log, we have been executing a lot of tests which were not related at all with the change that I have done. So now let me show you how smart testing works. I've already have smart testing here installed. I will show you later how to install it. It's really easy, but it's to install a Maven extension, you just need to create a .maven folder and extension.xml and just put it the smart testing lifecycle extension and that's all. I'm going to show you how to create this file later. So now I'm going to do the first thing. You just need to do maven clean test -d smart.testing equal new and change it. Now, what's happening with just adding this property is like only the tests that are new or that has been changed are going to be executed. I know that this is not so smart, but believe me, with just this thing, you're going to speed up a lot your pipeline, right? Because maybe in the first commit, you only want to validate the new test, not the old ones, as a first step, right? To validate that everything works as expected. So now you're going to see that building reviews MPL is going to compile it again. But now when it's trying to execute Surefire, it says, is there any test in the reviews model that has been changed or has been added? And obviously, smart testing says, no, there is nothing new. So it says, okay, if you check it here, you see that there is no test run. Although this project has tests, since there is no new, no changes, then it just skips. Again, it's happened the same with the tails. The tails will say that there is no test to run, 0. So it goes to the game page EMPL. And now in this case, it says, yes, there is one new or changed test class, which is the game service test. So now it's going to run just this test. Notice that now game service test is the one that's going to run because it's one that I've changed, adding a new test method. Now it runs and the build is success, but I only run this service test. This one, now I'm going to commit this to just have a claim. Now you said, okay, that's great, but it just checks if there is new things on the test. But usually my changes are on the production code, not on tests. So what I'm going to do now is just do another change. In this case, I'm going to change the review class, which is a JPA class. I'm going to change here that now the rating, instead of being from 5, it's going to be from 6. And okay, I want to do the 6. Now, of course, if I do Maven, if I do this, it's going to run nothing, 0 tests. Why? Because there is no new test and there is no changed test. I've changed a production code. So to fix this, we created another strategy which is called affected, which basically does something really, let's say, a smart, which is like, okay, I know that you have changed review.class. Then I'm going to explore all your class path, finding which classes uses this review class. And from these classes, again, all the classes that are being used. So it's like, creating a hierarchy of direct and indirect relationship between the modified class and all the classes that uses them. After that, what we do is saying, okay, of all this hierarchy, let's find which tests test some of these classes and add it on the test plan. So with the fact that the strategy, what we are effectively done is just finding which test verifies a production code. In this case, you will see that I changed reviews entity. So obviously, I'm going to run tests of the reviews module because it's where this review class stands. But if you check now, for example, here, wait, this is reviews. Notice that it's running review service test because review service test is a test that uses the review class. And also it's running the review test because review test is a test that verifies the review behavior. So we detected that these classes are using review, so we're going to run this test. But no more tests are going to be run. Details module just uses details, no reviews. So since there is no direct or indirect dependency between details and review, then no tests are going to be run from details module. Notice that 0 tests are run. And then it's going to happen exactly the same with game page MPL. And then it's going to execute no tests. Notice that it works pretty slow. This is because all the CPU is just spend it on sharing my screen. There's some things that sometimes happen in my computer. Well, when I do this sharing the screen. So I don't know if now. So it's like, okay, everything is success, but I've executed only the test that reviews what reviews class were used. Let me do exactly the same to have a clear. Now you will say, okay, that's great, but what's happening with other files? For example, if you check here in game page, you can see that there is persistent.xml, and this is not a Java class. But if I change this, probably you want to also validate that it's working as expected. For example, let me do one change here. I changed the database location. Then if I want to execute any test because of this change, for example, I want to run this test, the only thing that I have to do is just go here and say, look, I want to execute also this test when I watch this file. And the file that I'm watching is source test sources slash persistence.xml. So now what I'm saying here is like, okay, if I change persistent.xml, please execute this test, because this test validates that this persistent.xml has been correctly created. So I can go here and I do Maven affected, and then again, what's going to happen now is that it's going to execute only this game test because the change is just a file changes, and I instruct smart testing to just run tests called game test. Now, again, I mean, it's running all the builds, but only Then you've seen here like these three strategies. The newest strategy, which is for when you created a new test. The change to strategy, that this is run when you change a test. Then you've seen here affected strategy, which is run by inspecting your code. Basically, we are inspecting the byte code, and we are building this graph of dependencies, and then we just explore and run the tests that are really important for that change. Also, now you've seen that with affected, you can also be used with when you change a file which is not a Java file. But we also have other strategies, like for example, failed strategy, which what it does, this strategy is checking the previous run, and all the tests that have failed are put it as an important test. So this is really useful. Sometimes when you run your test from IDE and it works, but then you go and you do Maven clean test and it does not work, and you say why it's working with IDE and not with the Maven, and you start doing some kind of debugging, but you are running all the time Maven clean test. Wait until all the tests are run, or until it's time to run your test and then start debugging. With the failed strategy, what you are getting is that you only run the ones that failed before. So it's really speed ups this use case. And well, now let's see if it works, this test. Yeah, notice that now game test is run, and it's just game test. None of the other tests are being run. Well, I've killed the JVM for the reason it's failing. No worries. Then let me show you the last strategy, which is called categorize. And now suppose that what you want to do is run one test just because it has a category. For example, game resource REST API, it's a test that maybe you always want to run because it's really important, right? Then you can put something like using the category annotation. This category annotation is the one provided by JUnit, and I've created a new interface which is called a small test. So what I'm saying here is that this class is one of it's one for the small test. Then what I'm going here, and I said Maven clean test smart testing categorize it, and then you put something like this, which says minus the smart testing categories, and you put here the class of the category. Then when you run this, what's happening is that I'm only going to execute the tests that are annotated with the category smoke test. So notice that now I'm just using one strategy every time, but you can concatenate. This smart testing property can be set with, it's a comma separated value property. So you can put, for example, that affected comma categorized. And then in this way, you're going to always run only the tests that we think that are important, plus the tests that you as a person thinks that are important. So you can categorize your test and then let a smart testing just plan the test execution by just selecting the important test plus the test that you have instruct us to also run. So now you will see that reviews test will run no test, details model will run no test. It's 0 because there is no test annotated with a smoke test. Details, it happens exactly the same, and then you have the other test which is annotated with a smoke test, so it's going to run. I'm going to leave it here running. Well, yeah, because now it's this that takes a bit of time, but let's wait. Notice that now only game results REST API is run, no other test. And this is because I'm applying the strategy of categorize, and this class is categorized with the category that I've set. Finish this. Okay, we've seen the demo. Then Smart Testing has a website, which is you can, or not a website, but all the documentation is in archilian.org/smart testing. The thing that is important is that it's a Maven extension. It means that it's not a plugin. And it means that as it's a Maven extension that needs to be registered in the .maven/extension.xml, but you don't need to remember this because you can just do this cool -ssl and this URL/bash in the root of your project, and then smart testing will be installed as a Maven extension automatically. We have seen here the selective mode. This means that it only runs the tests that we think that are important, but we have another mode which is called ordering, which basically instead of just running the tests that we think that are important, what we are doing is just ordering the tests for important. So the tests that are more important are run first, and the tests that we think that are less important are run last. In this way, you can enable this fail fast behavior. So it's like, okay, I don't want to skip any test. I want to run all of them. But if the first one fails, I don't want to wait until the end of all the run to validate that the build is failing. Just fail at that time because I know that the build is failing. We have seen some heuristics, new changes affected, categorized, and the failed one, which is missing here, but there is this failing strategy that I mentioned before to run tests that has previously failed. Now we've seen that we are always running smart testing from the current commit, but you can also set a range of commits. So for example, you can say, I want to run all the new and changed tests from this range of commits. For example, from version 1 to version 2. So instead of running all your build, you can say, okay, let's run only the test that has been added between these two versions. It can be configured as system properties, we have seen here, but also you can create a YAML file, which can be put globally in your root directory or per module in each module, and then you can configure everything that you've seen as a system property, but as a YAML file. So then you only need to run Maven clean test, and then we detect this special YAML file, and then we just configure smart testing with these parameters. We also provided a Jenkins pipeline shard library. So if you are into this Jenkins 2 pipeline as code, then you can also use our shared library to run all these process automatically in your Jenkins. And as a bonus track, we are working in a test hub, which basically it's a hub where we are going to store all the tests. And this will mean that we will be able to exploit all this information for getting better results on smart testing. And that's all. We have covered just one part of speeding up your development, but this is just one way of speeding your release process. But again, if you want to speed up your deployment, you also need to try new techniques such as consumer-driven contracts, service virtualization, or testing in production, apart from using smart testing. And that's all. Just if you have any questions, feel free to ping me on Twitter or just send me an email. And of course, feel free to join the Red Hat developers community. Thank you very much.
Hey, Alex, you ready for a couple questions? Or did he take off on me? Oh, there he is. So real good question. Based on what you're demoing, and I know you're having CPU problems there, it would be nice to see the before and after effects from a timing standpoint. You know, the dumb testing versus smart testing. Is that possible, or did you have that in the presentation?
No, we don't have this, because it means that we need to know what happened in the previous build to be able to compare. We can just, because I mean that at the end, the only thing that we are doing is just removing some tests from the test plan of Surefire plugin. So we never know what will happen. You can do it on you as a developer to try it, but not automatically. It's true that when we have this test hub server integration, then we will be able to provide this information, because with test hub we will have information of the previous runs. So we will be able to say, look, the previous run was not running by smart test, and then this is by smart test as you have improved this time. Yeah.
Okay. Another good question I thought was nice is, can we make it the default so when I just run mvn test, the smart testing is run?
Yeah, well, more than default, what you can do is just create a smart minus testing.yaml file, and then configure there the mode that you want to use, the strategy that you want to use. I mean, there is a lot of parameters to be set in all these strategies. You can configure it there, and then you can just run maybe clean test. And then instead of using the system property, runs these configuration parameters from that file.
Okay, that'd be a good an example of that file would probably be good to get out to the world, maybe on Twitter. One other question is, what about mocked classes? So if you have mocks in your test, how are those impacted? Is it picking up mock classes also?
Yes and no. I mean that if you're mocking an interface, then if you change the interface, then it's detected, because this interface is it's imported in the test. But if you, for example, you're changing the EMPL class, I mean that the implementation of this interface, then since the implementation is not modified in the test class because it's not imported, then we are not able to detect it. This is going to change. I mean that there is a workaround, which is like we have a special annotation, as we see that watch for. Then you can use also an annotation to set, if I change any class of this package or follow this pattern, run also this test as well. So if you're mocking, then you can even instruct to run this test as well. And in the long-term support, what we are working is like in inspecting the coverage. So if you are running coverage, we will know that this test has covered all these lines of code. So then we will be able to automatically detect these changes. But in any way, that if you are mocking an interface, and it means that you are not testing the implementation, right? Because you are mocking an interface. So I don't know it has so much sense to run this test if you change the implementation, because at the very end you are mocking the implementation, right? So yeah, I suppose that there is a use case.
We are unfortunately
yeah.
So we're unfortunately out of time for today. Thank you so much. But there was one question and an item in the chat you'll want to think about more. Maybe put this out on Twitter also, is what about Gradle? But we'll just leave it right there. You can think about what you're going to do from a Gradle standpoint, unless you're just saying, oh, it's available already. That's not true, right?
No, that's true. No, because we tried, but it's really hard for Gradle. So yeah.
Well, thank you so much. And thank you all for joining us today from all around the globe. We appreciate you showing up. And if you ever have questions, feel free to hit us up on Twitter or find me on email. And feel free to give us new ideas from future events. And always go to developers.redhat.com/DevNationLive for more information. Thank you so much. Thank you, Alex.
Thank you very much. Bye.